All right, good morning. So we're talking about function operations here. This one shouldn't be that bad. I'm gonna do all the odds. You're gonna handle all the evens along with the odds that you copy down. So this is g plus f. This is g of x. This is one function. This is another function. All we're doing when it says something like this is taking these two functions and adding them together. So we would take the negative 3x to the third minus 3x squared, which came from g, and adding that to f, which is 2x minus 2. Now, can we combine any of these like terms? Absolutely not. So that's it. We're done with that problem. Now, when we get down here, another addition problem going on right here with number 3. G of a plus h of a. That just means take these two things and add them together. So it'd be 3a minus 1 plus a squared plus a. So we have to write this in descending order. So I'm going to start with the a squared. And then I can combine these two. 3a plus a is 4a. And then put the minus 1 there. And that's all you have. So just adding two functions. That's really all it is. Now, down here at number 5, we're taking f and subtracting g from it. So it's literally f minus g. So it'll be n to the third minus 2n, but we're subtracting g from it, which means this whole thing. So minus 3n minus 4. So we're subtracting the whole thing, which means this. We have n to the third minus 2n, but then we distribute the negative. So it's minus 3n, and then it's plus 4. So what we're going to do there is we're going to combine the like terms here and here, and I end up with n to the third minus 5n plus 4. So another subtraction problem here on number 7. We're going to take f of x, which is x squared plus x, and we're going to subtract this whole thing. So minus parentheses 3x minus 2. So it'll be x squared plus x, but then we have minus 3x, and then plus 2. Super important there. So we have x squared minus 2x, and then plus 2. That's it. Done. Then down to number 9, we have a multiplication problem, which means we take h times g. So we're going to have x minus 1 times x squared plus 5. So this is just double distribution here. So x times all this, x squared plus 5, and then minus 1 times all this, x squared plus 5. So this would be x to the third plus 5x minus x squared, and then minus 5. So now the only thing left to do is to put this in descending order. So this would be x to the third minus x squared plus 5x minus 5. And that's what you need to have for number 9. Wrapping up the front page here, or the first page I should say, first side, we're taking h and multiplying it by g, so we have negative x plus 1, and we're multiplying that by negative x plus 2. So here we go. Negative x times all this, negative x plus 2. And then I have plus 1 times the same thing, negative x plus 2. So this will be positive x squared minus 2x, then minus 1x plus 2. So it's x squared minus 3x plus 2, and that's going to be your final answer for number 11. Okay, now we have some division problems. So here's what we have on number 13. Now, it's going to look way easier than it is, but I have to talk to you about a couple things. Here we go. Anyway, it's h divided by g. So I'm going to put h on top of g. So it's going to be x to the third plus x squared over negative 2x minus 1. Now, with division problems, what I'd like to see here is I'd like to see some factoring, possibly, and then I would like to see what the denominator can't be. So some restricted values, if you remember that from last chapter, maybe, or even earlier this chapter, who knows. But anyway, up top, I could factor out an x squared. I'm left with x plus 1, which is great. On bottom, you can factor out a negative 1. You're left with 2x plus 1. Now, it doesn't have to look like that, because technically, that's our answer. But I factored to see if I could cancel anything out, if I could get rid of anything. You can't. So that's why I went backwards and said, okay, that's fine. But to figure out what we can't have is what the denominator would be set equal to 0. So negative 2x minus 1 equals 0. We're doing this to figure out restricted values. So if I add 1 to both sides and then divide by negative 2, you get x is equal to negative 1/2. That's what x cannot equal. So I want to see this, which is one answer. I also want to see this, which is the restricted value. That's whatever what you can't plug in. That would be a problem with the domain, all the x values. All right. So if you ever see something that asks for the domain, this one you just write x cannot equal negative 1/2. You could even write all reals except except negative 1/2. Either way, I would like those answers. Okay. Now, on the next one we have g. Oh, hello. Sorry. We have g. Oh no, come on. There we go. Now we're back. So we're taking g and we're going to put it over h. So 3n minus 1 over n squared plus 3n. So the first thing I recognize is that the top cannot be factored. This is 3n minus 1. But the bottom can. We can take an n out, and we're left with n plus 3. So, ladies and gentlemen, here's our issue. This is done. We can leave our answer like that, or we could even leave our answer like this. The only problem is, what can't n be? So you're going to take each of these and set them equal to 0. So n can't be 0, otherwise we'd be dividing by 0. Can't have that. We also are going to set n plus 3 and say that can't equal 0 either. So we're going to subtract 3 from both sides. We get n cannot be negative 3. So our domain would have this and this in it. Can't have 0 and negative 3 in our domain. Those are the x values, or n values if you will. Okay. Now, when we are evaluating or figuring out whatever this is, it's kind of the same thing we were doing before, but not quite. Now, you can do this a couple different ways. You could go ahead and just take these two functions and add them, and I'll show you that. It'd be negative 4x minus 5 plus x squared minus 3x. Let's combine some like terms. So I have x squared minus 7x minus 5. Okay. But we're going to try and evaluate that for when x is negative 8. So what you could do is this. Plug negative 8 into this. Negative 8 squared minus 7 times negative 8 minus 5. So it'd be 64 plus 56 minus 5. 64 plus 56 is 120. 120 minus 5. So our answer should be 115. I believe. Man, I hope I don't get that one wrong. Yeah, I'll stick by it. Now, another way we could have done that is plug negative 8 in here and here, and then just take those two and add them together. So let's see if that one works. So if I take g of negative 8, that means I'm substituting negative 8 in right here. So this would be negative 4 times negative 8, and that minus 5. So this would be 32 minus 5, which should be 27. Okay, so that's what we get from g of negative 8. G of negative 8 goes right there. Now this one, down here, f of x, when we plug that in, that's going to be negative 8 squared minus 3 times negative 8. So this would be 64, and then a negative times negative is a positive, so plus 24. So 64 plus 24 is going to be 88. And now, since I have g of negative 8 here, and this is f of negative 8 here, all you have to do is take these two, add them. 7 plus 8 is 15. 100. Oh, we got the same answer. Right on. So you can either add the two functions and then substitute, or substitute and then add what you get. So either blue or red. You pick away. Now this one shows exactly what I was talking about before, where when you're adding, you just take these two and add them. You just have to plug in negative 6 first. So I'll do that way. So we have negative 6 squared minus 2. So it's 36 minus 2, which is 34. Boom, baby. Then here I have 4 times negative 6 plus 4. Now 4 times negative 6 is negative 24. Negative 24 plus 4 is going to be negative 20. So when since we're adding here, add these two. 34 plus negative 20 is going to be a positive 14. That's it. Now, had I done it the other way, which is we take the two functions and you add them and then substitute, you'd have n squared minus 2 plus 4n plus 4. So this would be n squared plus 4n plus 2. So if you substitute negative 6, it would look like this. Negative 6 squared plus 4 times negative 6 plus 2. So it would be 36 minus 24 plus 2. This would be 12 plus 2, which is 14. You get the same answer either way. All right. Now, with subtraction, it's a similar type of situation here, but I'm just going to go ahead and substitute this in and then subtract them when I'm done. So if I plug in a negative 9, this would be negative 9 minus 2, which is negative 11. Now down here, on F, I have the opposite of negative 9 minus 4, which would be 9 minus 4, which is 5. So this is G of negative 9 right here. And this is AF of negative 9. And so we have to subtract these. What is negative 11 minus 5? It should be negative 16. And that's going to be your answer there. Now 23 is an easy one. If you plug in 0 into G sub n, so G sub 0 would be 0. If you plug 0 in right here, it would be 2 times 0 minus 2, so it would be negative 2. If you have 0 minus negative 2, it's going to be a positive 2 right there. All right, cool. All right, keep rolling here. We keep rolling. This is what we have now. We're taking these two functions and multiplying them. So f of 2, let's find f of 2 first. So if I plug 2 in here, that'll be 2 minus 2, which is 0. So that's f of 0 or f of 2 right there. Now we're taking that and multiplying it by g of 2. So if I plug in 2 here, this would be 3 times 2 plus 5, which is 6 plus 5, which is 11. So that's 11. So 0 times 11 is 0. And that's what we get for number 25. Okay, number 27, similar problem. Okay, we're going to plug in 1 for g. So g of 1, that's what we're doing first. It's the same thing as negative 2 times 1 minus 3. So it'd be negative 2 minus 3, which is negative 5. All right, so that's my first. That's negative 5. Goes right there. Sure. H of 1, which would be h of 1. It's going to be 1 squared, plug 1 in, plus 2 times 1. So it'd be 1 plus 2, which is 3. Now when we take these two and multiply them, negative 3 times 5 is negative 15. Dunzo. All right, last two, we got some division problems here. Here we're plugging in negative 8. So to find g sub negative 8, this is what we do. It'd be negative 2 times negative 8 squared plus 4 times negative 8. So this would be negative 2 times 64 minus 32. This would be negative 128 minus 32, which is going to equal negative 160. So that's our numerator. Since g goes over f, it's technically g of negative 8 over f of negative 8, which would be negative 160 on top. Now, changing the color so you can keep track. For doing this one, this is a little easier. We have 4 times negative 8. This is to find f of negative 8 minus 2. So this would be negative 32 minus 2, which is negative 34. So then my denominator is negative 34. So we can simplify this by dividing them both by 2. Negative 2. This would be 80 over 17. That's all you should get. All right. Now, similarly, let me change my color here. We have g of negative 5 over h of negative 5 down here. So if we plug negative 5 in, that's 2 times negative 5 minus 5, which would be negative 10 minus 5, which is negative 15. So that's my numerator. So negative 15 is on top. We plug it on bottom. Let me change the color so you can keep track. So that's 2 times negative 5 minus 2. So this would be negative 10 minus 2, which is going to be negative 12. Now, these two are both divisible by 3. So when you put one over the other, you can divide them both by negative 3. You end up with 5 fourths. Yeah, there we go. And that should be your final answer there. All right, thank you. Thank you for copying those down. Make sure you get all the evens.